All right, our final section of this unit on probability deals with what's called compound events. We have talked about simple events, which is where one thing takes place, such as flipping a coin, rolling a die or dice, pulling a marble out of a bag. But now we're going to get into what is called compound events. Our central question, just like the previous video, don't get scared by how long the central question is. This again is a fairly easy concept. So our central question is, what makes an event a compound event, and what are the different types of compound events? All right. Ignore what I have at the top right now. All right, a compound event consists of two or more simple events. So a compound means more than one. It's where there are two or more. We have what are called independent events. Independent events are when there are two or more events in which the outcome of one event does not affect the outcome of the other event. For instance, if I'm driving down the road and I stop at the mall, that has nothing to do with you eating at McDonald's. Okay? So one event does not affect the outcome or the other event. We have what's called a dependent event. All right, let's say you're riding down the road and unfortunately there's a wreck down the road that you're going down. That wreck may impact or influence your drive because you may have to take a detour. You may have to go a different way. So that affected it. A dependent event is when there are two or more events in which the outcome of one event, such as that wreck, does affect the outcome of the other event, meaning that wreck affected your driving, affected which direction you're going. All right? When we have compound events, let me highlight this right here. We have two types of compound events. We have independent events and we have dependent events. When we have compound events, the way we're going to write the probability is you'll notice right here we have the probability way of writing, for instance, the probability of A and B. And down here, the probability of selecting A and B. The word and means multiply. So when we have compound events, when you see the word and, you're going to multiply. Okay? So keep that in mind. So let me scroll back up to the top. Let's say you have a dice and you have a coin. And we want to know the probability of rolling that dice, getting an even number, and then flipping that coin and landing on tails. So let's do this. We have a dice. An even number on a dice would be rolling that dice and then landing on a 2, 4, or 6. So our probability of an even number would be a total of 3 out of 6 sides. So 3, 6. Our probability of landing on tails for a coin that's flipped would be 1 out of 2. So 1/2. So what we're going to do is we're going to take the probability of the first one, an even number, which is 3, 6. The probability of the second one, which is tails, 1/2. And all we're going to do is multiply them together. So our probability would be 3/12. And then, of course, when we simplify, you would get 1/4. And that's what compound events are. It's a very simple concept. So compound events, when we're finding compound events, you multiply. Okay? All right, let's look at this example. You toss a penny and a nickel. What is the probability that both land on heads? So the way that we're going to write this is the probability of heads followed by heads again. Sometimes you'll see it with parentheses. Sometimes you'll see it with a little and symbol or the word and. So our probability of flipping the coin, that's a penny, and it landing on heads, is 1/2. The probability of flipping the other coin or the nickel landing on heads is 1/2, which gives you 1/4. So our probability of flipping a penny and a nickel landing on heads and heads for the other one would be 1/2 times 1/2, which is 1/4. All right, this was an example of independent events. Flipping the penny had no influence or did not affect the outcome of flipping the coin. All right, let's now look at an example. Well, first of all, here, let me let you go ahead and copy this so that you know that that is independent event. Let's now look at an example of dependent events. All right, so let's say we draw a card from a deck of cards. We do not replace the card. What is the probability? So let's think about this. You have a deck of cards. We want to know what is the probability of drawing 2 clubs. First of all, you need to make sure you understand how many cards are in a deck of cards. There are 52 cards. All right, so what is the probability that you will draw 2 clubs? So before we get started with this, all right, you draw a card from a deck of cards. We want to know what is the probability of drawing 2 clubs. And we are not going to replace the card, okay? So that means when we take it out, we're going to leave it out. So our first probability is 13 over 52. Now, how did I get 13? Because a card is made up of 4 suits. You have clubs, you have spades, you have hearts, and you have diamonds. Each set or suit is made up of 13 cards. And if you add these 13s together, you come up with a total of 15 cards for a deck of cards. So we know that we want to figure out for clubs. So we have 13 clubs. So our first probability is 13 out of 52. All right, we're going to take that card out. We're not putting it back in. So when I do not put that card back in, we now have 51 cards. All right, we're going to assume that we took out a club the first time. So if I took out a club, that means we now have 12 total clubs. So our second probability is going to be 12 out of 51. So we multiply the 2 together, and when we multiply the 2 together, multiply the fractions, 12 times 13, 52 times 51, you get 156 over 2,652. And when you simplify, you get 1/17. So our probability of drawing a club, not replacing it, and drawing another club would be 1/17. All right, what I want you to do now is this example. So I'm going to put a little mark here. So if you'll do this one, if you'll work through that problem, and then if you'll work through that problem, and that leads us now to where we are finished. And so for this test, our probability digits assignments, you have 16-1, 16-2, 16-3, 16-4, 17-1, and 17-4. So you have these various assignments here. And let me get this to where you can see everything. So those are your different digits for this unit.